In this video's lesson, we're going to wrap up Unit 2 by talking about matrix multiplication. Just as a reminder, we've already seen a little bit of multiplication in the previous section where we talked about scalar multiplication, in other words, multiplying a matrix by some constant, which essentially increases all of the values of that matrix by that particular value. We're now going to look at how you can actually multiply matrices together. Now, matrix multiplication is a somewhat complicated procedure. So I'm going to take you through a couple of more simple examples, and then for more complicated examples, we will just resort to using the graphing calculator to show those. So, to first begin with multiplying matrices, it's important to understand kind of how this works. In fact, for matrix multiplication, you don't necessarily want for the matrices to be the same dimensions. In fact, oftentimes you want for them to be different dimensions or have different orders. And so here's what you must have, is that the number of columns in the first matrix must be equal to the number of rows in the second. And then as far as multiplying goes, when you multiply column by row, it's going to give you that column and that row a single entry for the new matrix. And again, we'll be looking at some examples. So if that doesn't quite make sense right now, what we're doing, that's going to hopefully make more sense as we go through some examples. So let's go ahead and take a look at a couple examples by hand to see how this works. And then, like I said, for the rest, we will resort to using a graphing calculator. So in our first example, notice that we have a 3 by 2 matrix, so 3 rows by 2 columns. And our second matrix is 2 by 2. So the number of columns in our first matrix is 2. Actually does in fact equal the number of rows for our second. In other words, you're checking the two inside numbers to make sure that you can actually multiply these matrices together. Now it actually turns out that your final answer is determined by the outer numbers. In other words, our final answer in this case should end up being a 3 by 2 matrix. So here's how this is going to work, is you're going to take your column multiplied by your row. So your first row of your second matrix, or of your first matrix, is going to be multiplied by this column in your second matrix. And so the way that works, the 4 will be multiplied with the 5. And the 8 will be multiplied with the negative 4. All of that together is going to become the very first entry. I'm going to make it a very large matrix. And what's going to become a 3 by 2 matrix. You're then going to take that same first row of 4 and 8 multiplied by your second column. So that would be taking 4 multiplied by 1, and then taking 8 multiplied by 3. And so that's the first row multiplied by the second column, and so it will be the entry on the first row and second column of your new matrix. We'll then take our second row multiplied by the first column. So we'll take negative 9 multiplied with 5 plus negative 7 multiplied with negative 4. So again, that's taking your second row, multiplying with your first column. So that becomes the second row and first column of your new matrix. We'll then do the same, take negative 9 and negative 7, multiply those with 1 and 3. So negative 9 multiplied with 1 plus negative 7 multiplied with 3. Finally, we'll take our third row multiplied by our first column. So that would be taking 0 multiplied by 5 plus 1 multiplied by negative 4. And so again, that's your third row, first column, and notice that becomes the entry in the third row and first column of your new matrix. You'll then take 0, 1 multiplied with the 1 and the 3. So 0 multiplied with 1 plus 1 multiplied with 3. All right, and then we're just going to simplify that matrix that we wrote down. Make sure to keep the entries separate, so don't think that you're multiplying in between these parentheses. Those are actually going to become separate entries. For the first entry, you're going to take 20 minus 32 is negative 12. The second is taking 4 plus 24, which is 28. We'll then take our second row, so negative 45 plus 28 is negative 17. And then negative 9 minus 21 is negative 30. And then for our final row, we'll get 0 plus negative 4 is negative 4. And then 0 plus 3 is positive 3. And so then here is our final answer, which notice is in fact a 3 by 2 matrix like we expected it to be. And there's how we'll leave our final answer. All right, let's go ahead and look at one more example by hand, and then we'll use the graphing calculator to work through the rest of these problems. So for our next set of matrices that we're multiplying, notice that the first matrix is 2 by 3. The second matrix is 3 by 2. So notice once again that those inner dimensions match up. The outside of those dimensions is then going to be the size of your new matrix. So we should end up with a 2 by 2 matrix for our final answer. All right, so setting this one up, let's first take our first row multiplied by our first column. So that would be taking 1 multiplied by negative 1 plus 2 multiplied by 6 plus 4 multiplied by 7. So you're matching first entry of each, so 1 and negative 1, 2 and 6, 4 and 7. We'll then take that same first row multiplied by our second column now. So that would be 1 multiplied by 5, 2 multiplied by negative 9, and 4 multiplied by negative 3. And again, you're adding in between all of that. So then that should be the first row, second column of our new matrix, and in fact it is. We'll now take our second row and do the same. So second row multiplied by our first column. So that would be negative 1 multiplied with negative 1, negative 3 multiplied with 6, and 8 multiplied with 7. We'll then take that same second row, now multiplied with our second column. So that would be negative 1 multiplied with 5, negative 3 multiplied with negative 9, and 8 multiplied with negative 3. All right, so now we should be able to combine everything to simplify this. So let's see what our matrix ends up being equal to. So we'd have negative 1 plus 12 is 11 plus 28 is 39. And then we'll have 5 minus 18 is negative 13 plus negative 12 is negative 25. So there's our first row of our new matrix. For the second row, we'll have 1 minus 18 is negative 17 plus 56. So negative 17 plus 56 is also going to be 39. And then for our next entry, we'll have negative 5 plus 40 or plus 27 is 22 plus 24 is 46. And so notice that our final answer is in fact a 2 by 2 matrix, and there would be your final answer. All right, so that's the idea of matrix multiplication. It does continue to work for larger examples, but again, due to time, we're just going to use our graphing calculator for those. Now for C, we shouldn't have to, because notice that in example C, you're multiplying a 3 by 2 matrix with a 3 by 2 matrix, and while it might be okay to add these matrices or subtract them, because the inside dimensions here do not match up, you actually cannot multiply these together. And that would be because the dimensions were not matched up, so dimensions were mismatched. In fact, if you try to type these into your calculator, you'll get an error message that says dimension mismatch. So that's what I want you to write whenever you cannot multiply, is that the dimensions are not matched together. But let's take a look at example D. So in example D, we've got a 3 by 3 matrix and a 3 by 2 matrix. This time the dimensions do match the way we'd want for them to, so we should end up with a 3 by 2 matrix. And again, we could do that by hand if we wanted to. We would take our first row multiplied by our first column, and that would be the first entry, and we could continue to do that throughout. But let's just take a look and see how this will work with our graphing calculator. So let's go ahead and type these into our matrix menu. I'm just going to type in the first one as matrix A. So matrix A is now a 3 by 3 matrix. And it on the first row is -1, 0, and 1. Second row is 5, 8, 7. Third row is 5, 6, 7. And again, we'll just make sure that it all matches up. Very important to make sure that your matrices get typed in correctly. So let's go ahead and type in our second matrix now. So we'll go back into that matrix menu. We'll go over to edit. I'm going to make the second matrix matrix B. So it needs to be a 3 by 2 matrix. So that would be 2, 3 across the first row, -5 and -1 across the second row, and -2 and 0 for the last row. And again, make sure it all looks okay, and I believe it does. So we can go ahead and close that screen. So remember, the first matrix was written as matrix A. The second matrix was matrix B. So we should just have to take matrix A multiplied with matrix B. So here's A multiplied with B. And as we expected, our new matrix is in fact 3 by 2. And so our final answer would be -4, -3, -44, 7, -34, and 9. So, while I want you to understand the idea of matrix multiplication and how it works for simple cases, when we get to larger cases, it's going to be okay for you to just put those into a graphing calculator and let it do the work for you. All right. Now, there are two properties that I want to talk about for matrices. The first is the commutative property of multiplication. The second is the associative property of multiplication. And we're going to talk about kind of when these work and when these don't. So for the commutative property of multiplication, remember that with numbers, if you take a number A multiplied by a number B, that should be the same as taking B multiplied by A. In other words, 2 multiplied by 5 should be the same as taking 5 by 2. And in each case, you get 10. So with matrices, we want to know if you take matrix A multiplied with matrix B, is that the same as taking matrix B multiplied by matrix A? So that's the question that we're looking to answer. So to do that, I've got two matrices we're going to look at. Let's first find the product of A multiplied by B, and then we'll find the product of B multiplied by A. And then we'll look to see, are they the same or different, and how we can tell by looking at their original orders. Okay, so let's go ahead and type these into our calculator. So we'll go over and edit matrix A to now being 1 by 3. So that would be 1 row by 3 columns, and the numbers are 1, -2, and -3. We'll then type in matrix B. So back into the matrix menu, over to edit, and this time for B, we're going to want that to be a 3 by 1 matrix, and the numbers are 9, -8, and 7. All right, so let's first find A multiplied by B. As a reminder from the scavenger hunt, we've already typed in A times B, So if we want to do that again, just press enter, and it will now give you the answer. So if we take A multiplied by B, we get the matrix of just a single element, which is 4. So let's see what happens when we take B multiplied by A. So we'll go into our matrix menu. This time we will have to type this in since we didn't have it before. So matrix B multiplied with matrix A. Here that is. And this time we actually got a much larger matrix. It looks like a 3 by 3 matrix. So 9, negative 18, and negative 27. The second row is negative 8, 16, and 24. The third row is 7, negative 14, and negative 21. So notice that our question up here, is A multiplied by B the same as B multiplied by A? The answer there is no. So the commutative property does not work for matrices. In other words, that the order you multiply in actually matters. So unlike with numbers, you have to be careful. Make sure that you're multiplying in the correct order. Now, how could we have told that by looking at the orders? Well, remember, A was 1 by 3, and B was 3 by 1. So when we took A multiplied by B, well, that was taking a 1 by 3 matrix and multiplying it with a 3 by 1 matrix, so we shouldn't have been surprised that that was going to be 1 by 1. But when we switch the order and now take a 3 by 1 matrix, multiply with a 1 by 3 matrix, now our final answer is going to be 3 by 3. So it shouldn't have been too surprising that our final answer ended up being different depending on the order that we multiplied the matrices in. All right, so now let's look at another property. Let's take a look at the associative property. So with the associative property, remember that for numbers, that says that if you take A multiplied by B multiplied by C, and you group up, let's just say B and C for this first one, then that should be the same as grouping up A and B and then multiplying by C. In other words, taking 2 multiplied by 3 multiplied by 4 should be the same as taking 2 multiplied by 3 and then multiplying by 4. So with numbers, notice that that gives you 2 multiplied by 12 or 6 multiplied by 4. And in both cases, you do end up getting 24 equals 24. So remember, associative property obviously works for multiplying numbers. So what we want to know now is, does it work for matrices? In other words, if I take matrix A multiplied by, in parentheses, matrix B multiplied by matrix C, is that the same as taking matrix A, multiplied by matrix B in parentheses, and then multiplying by matrix C? Well, let's find out. And in fact, to do that, I'm going to have us skip over this example. And we're going to go down to trying to show whether the associative property works. So again, we'll have a question mark for now. Let's see if we can, in fact, get this to work. So let's get this as matrix A, B, and then C. And then we'll group those up in the 2 different ways. So the first way, again, is to do B and C together in parentheses. And then the second way that we'll compare that to is taking A multiplied by B in parentheses and then multiplying by matrix C outside. So we'll look to see, are those 2 in fact equal to each other? So let's go ahead and put those into our calculator, back into the matrix menu. We'll make A our first 2 by 2 matrix. And it was 0, 1, 0, and negative 1. So there's matrix A. Then we'll get matrix B put in. So B is also 2 by 2, and it is 5, 6, 8, and 9. And now we can get our final matrix put in. So matrix C, which was negative, well, first is 2 by 2, so let me go ahead and get past that part. And then, yeah, we'll type in negative 3, 2, 4, and 7. All right. So the first way that we're going to multiply these together is we're going to take matrix A multiplied by, in parentheses, matrix B multiplied by matrix C. And when we do that, we get invalid dimensions. So let's take a look and see. I might have typed something in wrong here. So matrix A multiplied by B times C. Let me go back into my matrix menu. And we get 2 by 2, 2 by 2, 2 by 2. It should have worked. So let me see what's going on here. In fact, let's try doing this. Let's go ahead and try putting the multiplication signs in there. Okay, so that's all it was. So let me go down ahead and write that. So make sure and be careful, guys. I was kind of being lazy earlier with not putting the multiplication signs in. Make sure when you type that into your calculator that you do have the multiplication signs. Otherwise, you might get a similar error to what I did, in which case go back and double check to make sure your multiplication signs are in there. All right, so remember, if you want to change the way something was written, let's go ahead and practice that. If you hit second and then enter, it's going to pull up your most recent entry. So now what we want to do is we want to change where the parentheses are. So I'm going to delete where they currently are and then put them around A and B. The way you can do that without typing over A is to type second delete for the insert option and then put your parentheses in front. And then do the same thing after B, second, insert, and then do your second parentheses. Press enter, and hey, there we have it. So it actually turns out that the associative property does in fact hold for matrices. So the order that you group them in does not matter. So we can actually get rid of our question mark. It is in fact that they are equal to each other, and so it does hold for matrices. Write that a little bit better here. So the associative property holds for matrices, meaning that it is still true. However, the big takeaway from this today, guys, that I want you to have is that the commutative property does not hold. So the order that you multiply in does matter. The order that you group the multiplication in does not. All right, guys, that wraps up Unit 2. That is all we've got for this unit. Until next time, have a good rest of your day.